All right, U substitution can be a difficult process and it can be an extremely easy process. The big idea is that you guys have to choose the correct U. And what if you don't? Well, stop what you're doing, cross it out, and choose a new U. Okay? It's a pretty good life experience too, or life advice. You don't like what you're doing? Stop, choose a new U. Okay? Um, the only rule we have is just the trig rules for integration and the anti-power rule, basically. This is going to help us get it through everything else. Okay? Use substitution and recognizing patterns. This is a big thing. You got to recognize patterns. I'm going to hopefully give you guys some keys to help you make your selections quicker and to waste a lot less time. All right, the integrand each of the following integrals fits the patterns above. And integrate each. Okay. Now, before, the only way we could do this problem is to multiply this all out, which is extremely fun, and then distribute the 2x in, correct? But this problem is set up with a pattern. We're going to make a U substitution. We're going to create that f of u situation. Okay? That means u is the inner function. In this case, what do you guys think the inner function is? Yeah, x squared plus 1. I think that's the inner function. We have like a multiplying function out here, and then we have this composite function, and we have a product rule. It's just a mess, isn't it? So what we do is we over here on the side, I kind of like do some work here, and I do the u sub on this side, okay? So I'm going to say u is equal to x squared plus 1. So we're going to sub this stuff, and that's going to be the u, hence u substitution. Now, here's the problem, guys. We have a u sub, right? So we're changing this variable to a u, but we have a dx. That means we have to substitute that also. We have to make everything in terms of u up here. How are we going to do that? Well, let's take the derivative of both sides of this, okay? Take the derivative. Now, that would be du with respect to x, dx, equals, that'd be 2x, correct? But what in the world? It's just written as dx. Well, remember what I said we could do? We can multiply both sides by dx. Let's do that. And now we have du equals something times dx. Well, what do you know? We have a 2x over here we had to get rid of also. Remember I said we have to have everything in terms of u? So there's 2x dx, which is equal to du. We can substitute du for both of those items. So now our new antiderivative will be antiderivative u to the 4th power, and then du stands for both of these, right? Du. Questions on this so far? This is a lot easier to antiderive, right? Okay. What would that be? U to the 5th times 1/5 plus c. And guess what's the last step? Yeah, sub it back in. Let's take that u, sub it back in. 1/5 x squared plus 1 to the 5th plus c. And what is crazy, like we've said before, if you actually found the derivative of this, okay, you bring the 5 down, multiply, you get x squared plus 1 to the 4th times the derivative of the inside, which would be 2x. What do you get? You get the integrand. Okay? That's it. Do not multiply this out. Do not mess around with it. Just leave it how it is. Okay? All right, that's your first U sub problem. Let's do another one. What do you think U is going to be in this case? Yeah, x cubed plus 1, the inner function probably, right? Okay, U equals x cubed plus 1. And we need to get rid of dx. We need to write everything in terms of u, correct? Now, here's a little secret. We don't have to find the derivative this way. We can just jump straight to this. Watch this. Derivative of u, du, equals, what would that be? 3x squared plus 0 times dx. There we go. That's that's more streamlined. Now, we have to make sure everything is taken care of. Okay, 3x squared, we have that? Yep. We have a dx? Yep. So du is substituted in for both of those. And again, for some of you that are having a hard time seeing this, just watch this. I can rewrite this because it's all a product. So there's our du, and here's our u right here. Okay. So if you're having a hard time seeing that, making my substitution, that's why we can do it. So we have antiderivative square root of u du, and then we like to rewrite these ones correct. U to the 1/2 du, antiderive u to the 1/2. Again, I like to write down the base, add 1 to the power, multiply by the reciprocal, plus c, and then substitute u back in, plus c. There we go. Now, Mr. Bonley, how will this look on the AP test? Well, what they might say is, here's a function, or here's the antiderivative. If u is this, what will the other antiderivative look like? And they'll have that as an answer choice. Or they'll have this as an answer choice. Or if they say, find the antiderivative, they might stop right here on the answer choices. Or they might fully re-substitute back in. You just got to be aware of the surroundings on your multiple choice and answer appropriately. Okay? They don't always do the full problem. Okay? I understand. Is there really an inner function, or is this just a product? Well, think about this too. Watch this. This is also secant x squared tangent x plus 3 dx. Right? So could secant be the inner function? Right? Well, let's see. Let's pick u equals secant x. What's du then? What's the derivative of secant? Secant tangent. Now here's the deal, guys. Do we have secant tangent to substitute in up here? Well, it's some extra stuff here, isn't it? There's a sum or difference there. So guess what? Bad u choice. Pick again. Now with some of these, especially trig functions, I ask myself, which one is the derivative of the other one? Yeah. Yes, so if you take the derivative of tangent, secant squared, so that's what you want your u to be. Yep. So which one is the derivative of the other one? This is the derivative of the other one, so this is your u then. Okay? Because we're taking the derivative of u. So make u equals tangent x plus 3. Well, Mr. Bonner, there's a 3 here. Well, what happens when you take the derivative, though? It goes away, doesn't it? Okay? Du then equals secant squared x dx. And, okay, if this is my u, this is u, du is secant squared x dx. We have everything covered. No other manipulation will be needed. That's next. That's how we can ramp these problems up a little bit. Okay, that would be du, that's u. So this is just u du, and that's it. That is it. One nice thing about some of these trig functions, they look really messy at the beginning. You pick a correct u, the antiderivative is really easy. Okay, now watch me make a mistake now. What's the antiderivative of u? Okay, that'd be u squared. What'd you say? 1/2 u squared. That should be like almost automatic right now. You guys done it a couple times. Plus c. Make your substitution. 1/2 tangent x plus 3 squared plus c. Leave it like that. It's not tangent squared plus 9. That's foiling incorrectly. Questions on this? Well, what if things don't line up nicely? What if everything isn't covered up? Well, we got to adjust. So sometimes that du dx or just du does not match up nicely. Okay, what do we do? Well, we've got some problems for you to work on. We'll demonstrate what you got to do, and sometimes they call those minor adjustments. I don't know, is it a chiropractic thing we're doing or what? Nope. We're just going to use our math skills to make that du, or make sure we cover up all the leftover information in our integral. All right, for part A, what do you think we need to make our u? What? What's our u? Okay, when in doubt, inner function. This is set up pretty nice for this problem. U equals x squared plus 1. That means du equals 2x dx. Oh, crap. But what we have here is we have x dx, but we have 2x dx. Well, solve for x dx then. Divide by 2. 1/2 du equals x dx. Now we can substitute 1/2 du in for x dx. Okay. Now, again, I'm just going to reorganize this a little bit so we can see what's going on. Okay, so this would be x squared plus 1 to the 6 x dx. Okay. Now watch this. If we make our u substitution, that'd be u to the 6, and that'd be 1/2 du. Okay, because x dx is equal to 1/2 du, right? What can we do with constant multipliers? 1/2 antiderivative u to the 6 du. So anytime if you're going to have this constant out in front of du, that's going to go in front of your antiderivative. Okay, let's find the antiderivative. 1/2 times whatever we come up with, u to the 7th times 1/7 plus c. Now here's the deal, guys. I suggest you write this step out and then take care of your coefficients and make your resubstitution for u. So that'll be 1/14. U is x squared plus 1 to the 7th plus c, and that's our antiderivative. Okay, let's look at part B. Again, part B, we could not find this antiderivative without knowing u substitution. This is definitely a composite function, right? Outside function square root, inside function 2x plus 1. Not many things you can make your u choice with. It's pretty clear what you're going to make u. I'm going to say u equals 2x plus 1. What's du then? Then what? Dx. Okay. Now let's analyze our integrand. U covers up the inside of the radical, and then we just have dx left over. So guess what? We have to solve for dx. Okay, do that. 1/2 du equals dx. So we're substituting this 1/2 du in for dx. Let's rewrite our antiderivative. You guys want to use the advanced move and put this 1/2 out in front? Let's do it. 1/2 square root u du. We could have used a fatality and actually just went u to 1/2 power right away. That would have been really owning this problem, but baby steps. I played a lot of Mortal Kombat back in my days, kids. It came out when I was in high school, actually middle school. That and NBA Jam. All right, antiderivative then. U to the 3/2 multiplied by the reciprocal plus C. All right, would that be 2, 6, or you can cancel your 2's? What? This? No. 1/3. U is 2x plus 1, correct? 3/2 plus C. Now, I'm not going to lie, they might have this written as 1/3 U to 3/2 plus C as one of the answer choices, and they all might be in terms of U still. Every once in a while, they have problems like that. We just got to be able to adjust again. All right. I'm going to let you guys, we'll help pick out what the U choice is on part C, and then we'll let you guys go with it. Let's see what happens. What is U, do you think? That's what I would go with. See what you get. Okay, go from there, guys. All right. Okay, if U is that, then I get du equal, will that be 12x squared dx, correct? All right, using our critical thinking skills, we're thinking about this. Okay, this will be a u, so it'll be square root of u, or u to the negative 1/2, right? And then I need to cover up 7x squared dx. That's what I need to substitute in for, correct? All right, now there's a couple ways we can do this. Number one, 7 is a constant multiplier, just put it out in front. Okay, then we need to cover up x squared dx, right? We'll divide by 12. Okay, that's one way to do it. Okay, that's the way I like to use a lot of times. Okay, the other way is make this look like 7x squared dx over here. Okay, so we'll divide by 12. And how would I make this look like 7x squared dx? Multiply by 7. Well, if you multiply one side by 7, we got to do the other side. Multiply by 7, right? So it'd be 7/12 du equals 7x squared dx. And I think we might have been, this might have been the confusing part, how we didn't get this to be a 7 when I can't just like divide it over or something. So I forced the math to do what I want it to do. Okay, manipulate it a little bit, multiply both sides, legal steps, okay? Now, if I would do it the first way, I would have 7 out in front, antiderivative x squared dx. Okay, if I had it like this, well, 1/12 goes in front, so that's 7/12. And look at that, we have 7/12. Okay, either way is acceptable. Let's do it correctly. All right, now let's rewrite. Advanced move, putting that constant multiplier in front of our antiderivative. And I'm going to write this one way first. I'm going to write 1 over square root u du. Again, trying to skip too many steps. Now I'm going to rewrite before I take the antiderivative, u to the negative 1/2 du. And I know a lot of us can go straight from this to this, but some of us need this intermediate step to see things clearly and not waste time. Well, we got a constant multiplier, antiderivative. Okay, u, add 1 to the power, makes 1/2. Multiply the reciprocal, 2/1, plus c. A little time sign in between. And 2 and 6, so 7/6. And what was u again? 4x cubed minus 5. To the 1/2 plus c. Leave it like this, please. Just leave it. You could put a square root sign if you wanted to. Sometimes the answer choices have a square root. Me, just leave it like this. Yeah. Right here. Yep, but then you're canceling dx's and stuff. It works though, yes, definitely. Because, okay, dx would be du, so you'd have your 12 dx squared dx. Yeah, you can do that. That's fine. You can do that, yeah. Just make sure everything is in terms of u before you find the antiderivative. Okay? Trig. Guys, these are easy. These are really easy. Okay? Now, what's the problem? What's different between now and what we learned before? Well, it's sine of 2x, not sine of x. We have a composite function now. Okay? What do? U sub. Obvious choice for u. 2x, right? What's du then? 2dx. Do we have a problem here, soldier? Yeah, divided by 2, so 1/2. Du equals dx. Okay, this is now u. This is now du, and we'll have a 1/2 out in front, right? So this just turns into 1/2 antiderivative sine of u du. We know what the antiderivative of sine of u is. What would it be? Negative. What in the world? Negative cosine u, that would be correct. Plus c. Reorganize this a little bit. Okay, put the negative out in front. 1/2 cosine of 2x plus c. If you found the derivative of this using your chain rule, you would get this integrand sine of 2x. And really, really fast. U is theta over 4, right? What's du then? Say again? Say again? This is 1/4 theta, right? So what would it be then? One-fourth d theta, yeah. Sometimes we go to forwards in life. All right, multiply by 4 probably, huh? We don't have any other constants. This is our u, this is du, and we got the 4 out in front, right? Okay, sometimes it's helpful to see like that. Now, big question is, what's the antiderivative of cosecant squared u? Positive or negative cotangent? Negative cotangent? And then reorganize, negative 4, cotangent, would it be theta over 4? Plus c? When in doubt, u sub, folks. And who subs? You do.